Good morning, everybody. Today, we're going to be tackling a couple of different things. But as always, before getting started, a little coverage of what the hell I'm doing exactly. So, this particular stream on Saturday, what I have scheduled to do is cover the next chapter or two in the Go programming language, a book Alan Donovan and Brian Kernighan, or Alan A. Donovan and Brian W. Kernighan have written. It's a great book on Go, covers the topic thoroughly and intensely in pedantic detail. Love the book. Right now we are going to kick off covering a little bit of variadic functions. It's a thing that I haven't used very much, so it's a little bit of new territory for, well, me and prospectively you. And then we're going to jump into the next bit, which is going to be, it's way over here. Anyway, interfaces. Interfaces is what I'm trying to find. So if you want to follow along in the book, if you have it, methods. Methods and interfaces. Anyway, covered a lot of functions and method material last session. So I'm not really going to recover that too much, but we're going to be using what we learned in that session last time in this session with some of the code that we're going to be doing, code that we're going to be writing up. So I'm going to start off with some of the variadic functions. I just wanted to talk about that because I noticed we didn't cover it. I didn't cover it last time. And that's a little bit problematic because they're pretty important and they're pretty awesome too. Having variadic functions basically lets you write a function where the signature has X things in it, like an int or a string or whatever, but then you can actually continue and add a variable range of items to that signature dynamically when you execute the function. So instead of just saying, I want to run the function with this parameter, I can run the function with this parameter plus this parameter, this parameter, this parameter, and this parameter, and just add things to the signature. So it's kind of like JavaScript in that sense. Like JavaScript, you can just add in things. And the function may not do anything with what you add. It's a little arbitrary in JavaScript, but it's an interesting capability. And basically, you declare something like an int parameter to pass in, and then you just say, what is the syntax? It's let's look at it. Let me pull up the right screen here. We'll jump into our code and go through our normal morning practice. Let's create a new project specifically for this project, right? So learning Go episode 6. We're on episode 6. I've been doing this for 6 weeks now. It's been a lot of fun so far. I'm really enjoying this. So open it in this window and then add our normal stuffs, right? So Go file. This is GoLand, by the way, the IDE by JetBrains. It's super rad. Added the nyancat plugin, which you'll see on the little status bar there when it's doing stuff. And whenever we do a build, you'll also see the nyancat. It's one of my new favorite things, really. Add a git ignore. I don't know why I picked a Go file to create the git ignore in. What is the... I'm always confused. In JetBrains stuff, sometimes they have the rename, sometimes they do not. It kind of depends on the OS, I guess. So they bounce into the terminal, and I actually just want to rename. So move .git ignore to .git ignore. There we go. Okay, now it's a legitimate git ignore file. We'll remove that and then add all the stuff. I always like to just cheat and run out to GitHub. Let's go to GitHub here. And then I haven't been working on any of those projects. I don't know how it determines I guess other people have looked at those projects for me. So we'll go into 5 and we'll grab the getignore file from that previous thing here. There we go. Oh, almost lost my paste there for a second. So this is lesson 6, so we don't want that folder, build, etc. So we got all that added. And now just to make sure everything is right in the world at the moment, as we assume, checking. And then we'll add a little build just to make our process today go faster. Pick a package, and that's all we need. Whoops, I always do that. I always do that. I want a better name than the whole bloody thing there. So go, build, and run. There we go. It's easier to read. So there's Nyancat running down at the bottom, and then boom, we get checking. That's what we expected. All right, so everything's wired up. We're ready to write some code. The first thing I was talking about is this variadic function thing, right? I'm not really sure where the name variadic, or why they decided to, I should say, use the word variadic for this capability, for this feature of the language. But that being whatever it is, that's cool. It seems more a little like dynamic signature parameterization, but that would be probably just as bad to call it that. I mean, that's a tongue twister of stuff. So let's add the func, and then we'll say sum vals for values, right? And then dot 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 int, boom, and there we go. So let's call this sum, and let's start going through it here. We'll say 42 and 42 and 42. So see how I can just do this one declaration, and then I have 3 things now, right? I could just blah, 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 say whatever I want to here, and add whatever numbers, as long as they're all int, right? That is the catch. So let's continue onward here. Let's say print format, and then result, or let's say call it sum. That sounds more logical, right? And D, we'll do a new line. Then we'll add, oh, we need to add result, right? So that's going to be an int 2. And we'll use this as a function value. So we'll just say, just like that, right? So that's going to call it the format.f, oops, I don't need f. Printf is going to execute, right? That function has these 2 parameters passed, a function value, which the function value is then going to execute inside of this function executing, which will then get whatever is called in our func with our variadic function parameter list in the signature, and that will then spit out the result, and the result will be printed as the sum. Seems straightforward enough, right? So let's see here. We'll say total is equal to 0, and then 4, skip that thing, and then just say val. So the underscore is where it would have the index. Val is going to be the value coming out of vals, the particular value at that particular point in the variadic signature parameter. And then we're going to say total plus equals val. And then we should be able to just return that value, the summed value, right? That all make sense? I think that all makes sense. I'm also curious, what happens if I take this func and I put it in chat? Boom. Oh, yeah, it takes all the spaces out and stuff. That's what I thought. So, if I build and run it again, what do I get? There we go, sum 126. So let's add another one. Let's add 96 and then 102. Run that. 324. Looks good, right? So let's try 909, 2, 3, 4, 5, 4, 3, bitch to boot. We getting close to our limit yet? No. Let's add some more. Still not there. Oh, overflow. So that's what happens when we exceed the size of an int value, right? We'd have to move to a big int size, which in one of these sessions we're going to play with. But for right now, we have covered variadic functions. Now let's get in here and, oh yes, so we've created that. Let's go in here and get our get sorted, right? It's here. Pondering. Have to send a little tweet real quick. Boom. All right, so let's get in here. We're at 5, and what we want to do though, oh, I need to sign in. Oh, am I really signed out? This is crazy. Oh wait, maybe, was I using Firefox on this one? I think I was. There we go, already signed in. That's what I wanted to do. So new, we're gonna do go learning, go episode 6, yo. It's a lot of episodes. Episode 6 of my Learning Go series. Go ahead and create that. Is that actually what? Yeah, okay. I did use the same context naming there. All right, bear with me. Just doing a few quick little tweaks. Oh, crap, I think I just reposted a tweet. Doubled up there. That was not what I was trying to do. Haha. Quick cleanup of that, and then going over, checking, there we go, okay. Yeah, I don't think it's reasonable to try to live tweet my stream. Okay, so we're gonna get out of there. Get, add. Well, first I always like to check, right? Out of habit. Get remote -v checks. Okay, I've got no remotes attached to my Git repo. So get remote, add, origin, boom. Oh, I didn't copy it, damn it. Come on, copy. And then paste it. Oh, wrong bash. Paste, there. Boom. What? Oh, derp, get init. I should have actually read the fatal error in the thing right before, and I would have realized that that's not what I needed to type. I needed to start the Git repo. So get init, that gives us an actual repo. Now if I say get remote -v, it'll just show an empty list of nothingness because there isn't one attached yet. And then I'm just going to go back to my command, get remote, add origin, the actual URI for the get remote repo. Boom, added. So now that'll show up in the list as the fetch and push origin remote get repo access points or URIs. All right, so get status. Now we have the get ignore and the main. I always like to get add the get ignore first like so. The reason being, when I do my next commit or my next check, like if there's anything out of sync with the get ignore, like something that it's not actually being ignored because I accidentally already added it, I like to always put that as the first commit thing to make sure in practice that it kind of validates whether I'm missing anything that I need in there, because then I can do get status again, right? And all right, so it's just main.go. That is what I want added. So I'm going to go ahead and say get add. I could say -a, but I'm going to be specific. Main.go get commit. I'm just going to call it first commit using variadic functions. Whoops. There we go. There. And get push. And since it's the first push to the remote repo, I'm going to do -u because that will link and say map to this particular remote branch, which will be master, and this should stay in sync whenever we're doing get push, get pull, etc. So origin master, and we should be done there. So then I'm going to do get checkout -b for new branch. I'm going to check out the new branch that I am about to create. Okay. And I'm going to call it variadic function examples. Examples. Yeah, there we go. So there, now I'm in that branch, and I'm going to actually push that one too. Variadic function examples. And since I'm already mapped effectively to the remote get repo, I don't have to do the -u again, just get push. Oh, I do need to say get push to which source. So origin, that's my remote one, and then push that up to it. So bloop, that should be up there. Oh, what does it say? Something nice. Oh, create a pull request on GitHub by visiting. Don't want to do pull request because I'm using each branch as kind of an example, right? So if we go up here though, and then just do a little refresh, got everything here. Oh, we should add a README. Let's do that. We'll do it via the interface here. And let's do, let's say, variadic function examples. Or actually, let's do functions. We'll make it a second level header and say examples, or write examples. And then here, let's make this a link, right? And then pull this up, and we'll get the link to that branch specifically. So that makes it a little easier to find, right? Click that, get the URI, go over here, and there. That'll work pretty good for our examples. I should go back and do that for every one of them. For anybody that's looking at any of these sessions, they can see other examples and have it mapped in the README. That should have been a no-brainer thing I did right off the bat when I started all this, but alas, I did not. So now though, let's do some little tweaking on this repo. We'll do get checkout master, get pull origin master, like so. That's going to pull the README. And there we go. And I'm going to actually then, so that's all synced up, but let's go back to that branch, get, I didn't want status, I wanted get branch, get checkout, variadic function examples, and then in there, we're going to add a README via the terminal. I'm going to add that content so that we have the same thing, right? So I'm basically, in each branch, I'm going to want the README to be the same no matter what examples I actually have. So you can kind of link back and forth to all examples and all the branches in the Git repo. I think that'd be pretty cool for everybody. So we'll keep up with that, and then I'll go back and sync all of them across all the branches later. But I need to do a Control-Alt-A, and what that basically does in the IDE is go here, and then add, Control-Alt-A, right? So that adds that for the next commit, and it'll go to green. If it's tan, it's not included in the next commit just yet. So this is the same thing as saying, like, see, it's green right there. If I had said git add readme like that, it would have added it, right? Same command, just one is via the IDE, one is via the terminal. Okay, it's good to know that in both places though, as you work through various IDEs with other people. Always helps to know how that is done in whatever respective environment that you're working in. Okay, so let's go ahead and push that too. We'll use the IDE one, adding readme to branch. Go, and then commit and push. A little nyancat starts working. Nyancat works some more. I mean, it's nice to see the stuff in the terminal when it goes through and gives you all the data, but it's also pretty cool to see the nyancat run across the screen, in my opinion, which is important. But here we go. All right, so main, go back in here. Let's do another variadic function and say sum and present, we'll call it. And we'll say vals int, and then let's do words string. Is that the way we declare it? I don't actually know. We're going to find out though. And then we'll say it's going to be a string response, right? Should we do that, or should we? Nah, let's do int and then string. So then we'll say well, actually we'll do total. No, I'm not rewriting it. Let's do first value is total. Yeah, we'll do this and then say sum, and vals is just passed in as vals, and we'll get that response, right? But then we'll say, let's say paragraphs or sentences or something, sentences. And then that will be to say. That's good. That's what I'm going to put. Just as an example here, to say, and we'll get that there. And then we're going to go through word from the range of words. And then in here, oh, the formatting didn't do right. Okay. And then we'll say word is plus equal to word, oh, whoops, I'm doing this wrong. Sentences plus equal word. So basically plus equal is the same as saying this. Okay, that would functionally give us the same thing, but it's a little more concise to say plus equals word. And then we're going to return total and sentences. Where is my no suggestion? That's a load of crap. Oh, because let's hear. Has both named and unnamed parameters. Oh, am I missing a? Ah, so this is a question. Can you only do one argument in a variadic function? What am I missing? What am I missing here? So I could pass to declare a variadic function, the type of the final parameter is preceded by an ellipsis. Right. Oh, the final parameter, which indicates that the function may be called with any number of arguments of this type. It's interesting. So okay, implicitly the caller allocates an array, copies the arguments into it, and passes a slice of the entire array to the function. So that's somewhat obvious if we sit back and look at this for a moment. So here in sums, vals is clearly an array in this context, right? So it's a slice array. Now, that is interesting because, oh, I just looked at one of the other things we can do. Let's see here. So it seems like only the last parameter in the signature can have this. So here I would have to say vowels, but it would have to be something like this. So let's see here, int. I'd have to make it an array, I believe. But that says that is not right either. Missing. Oh wait, maybe I did this again. You gotta have, oops, parentheses around the return functions when you have more than one. I always space out on that. So this looks a little bit better though. So this says can only use as final argument in the list. Okay, so yeah, I can't do this here. So let's make it an array, right? So vowels. And then if I pass this in, so then I could say this, something like that, I believe is the syntax. Yes. Okay. So here I have converted this vowels to, not converted, but I say basically take all these values and just string them out as individual elements here. So it's taking them out of an array, from what I understand, and then it turns them back into an array slice in here by inference. The language engine itself does that. So I believe we have what we want now. So for our next line here, format.printf, and we'll say sum is this value. And then we're going to do new line. Well, actually, let's do new line, and then sentence. Whoops. Space, and then that's going to be a string. So then we'll say, or we'll write. I got to start saying write. I'm not saying anything. Yes. You caught me on that, Dave. Good point. Also, welcome to the stream. So sum and present. So here I want to say, or I want to enter an array. So let's create an array first. Var the numbers. That's super original, right? Oh, I'm not doing that yet. Actually, yeah, let's do that. The numbers is equal to blah. Come back here. There we go. Oh, is it parens here? It's actually a little confusing now that I think about it. Hey, Clarkio. How you doing, man? How'd you get the little 18 in front of your name? Is that like a special drop or something on Twitch, or is that just like some ANSI code or something? What is this fussing about? Have I completely spaced on how to make a function? in Go. That's embarrassing. Golang int array. Oh, dir. Yeah, of course. Yeah, you have to say int. We'll say 3 here, or write 3. And then it is curly braces. That's what was confusing me. Goland actually confused me there, because it said do that. All right, there we go. This is in the numbers, and then we want to add some strings. So let's say hello. Can I do this? Yeah, all right. Hello. Cheeseheads of the world. Oh yeah, I could do that, right? That's a good point, Dave. Dave Dev. If I do ... then I can just whimsically add whatever I want to here. 62 and 102 and 9 and 23 and 64. That sounds groovy, right? Oh, okay. I got you, Clark. Clark.io. So there's our bunch of numbers. And then run that. Cannot use the numbers as type int, an argument to sum and present. Multiple values sum and present in single value context. Interesting. So I guess we can't do that. We're learning about limitations of Go here. So if I say pass in these like that, and I pass in the int here, so that should work, right? Type 8 int can't be passed into type int. Oh, so should I just do this? Is that gonna fix it? Oh, and then vowels is crazy. Cannot use vowels type int as type int array. Yeah, so I had to go back to this, right? Oh, we still have this though. So type int is type blah. So can I just do this? Oh, yeah. Okay, that makes sense. So now this is just a straight slice instead of a static array. That's one thing I find that they did in Go that's just super confusing, like compared to learning about arrays in other languages. But it's, I don't know, it's not that confusing based on, well, like, okay, so if you've learned C++, which I did 5,223 years ago, and you've learned stuff like C#, that array and slice paradigm kind of works to me. These are great glasses, by the way. These Pyrex, they heat up great, blah, blah, blah. You know what I mean? Usually you do experiments and stuff with them, right? But I just drink out of them because they're like $2 a pop. Cheapest, awesome glasses ever. Anyway. How the allocations are rationalized. Right. Yeah, I get that. I do have to admit, here I am trying to teach this stuff, and that still is a little difficult for me to explain, Dave Dev. It's cool that you pointed that out, though, because it's forcing the conversation, right? It does have to do with how Go is cutting and putting that on top of each other, or not, in the case of just a plain old array. Right, exactly. So when I first read about that, that was one of the things Yeah, maybe I'll have to do just a whole 20-minute session on that at some point. But that's the thing is I need to get my whiteboard out for that. And it's over against the wall. It's not, yeah, it's kind of like a sidetrack from just writing code and testing out the code. But suffice it to say, oh look, let's see, I still have a problem? I thought we fixed all of it. All the squigglies, or weird squigglies, went away. No argument for verb 2. Oh. Wait a second. I need to take that out of there because that is not a function value. It's a function with multiple returned values. So I need to say, what was it? Sum, and then sentence. I think I can just do that. There we go. That makes a lot more sense. But I don't know. Does that make it more readable, or does that just look bad, actually? I'll leave numbers up there. But the strings are on the second line, though. I want to be able to see it all on one screen, right? So now I can say sum. Now I can write sum and sentence. And that should make that work. I understand that error now. So it was saying single value context. It was assuming I was using that function as I had previously in the one above, where this is a function value because it returns a single value and can be used in that context because we're only going to get back the one thing, which would then be put into the string where the verb interpolates it. And then below, though, I needed to get the two individual values to pass them into the printf function so that it knew where to use the verbs to replace within the actual string. So sum and sentence then accordingly go in as the %d and %s. That's groovy. Nyan Cat for the win. Cheeseheads of the world. See, if I wanted to make this more usable, I'd want to put in like spaces, but have it go actually determine that, right? So I'm just going to do this for the moment. All right, so now the thing I was really looking forward to getting to here. So we covered some methods and other stuff last session, and we were kind of building up to getting into interfaces. So I'm flipping through. If you do have the book and you're following along, oh gracious, I keep like flipping right past it, but I'm just going to give you the page number in case you want to jump into it. So interfaces in Go are functions. How do I keep missing the page? Methods 6, and then methods. There's the interfaces. Flipped right by the page. Oh, no, one more. Yeah. Page 171 is where interfaces start. Interfaces as contracts, right? So an interface type express generalizations or abstractions about the behavior of other types. By generalizing interfaces, let us write functions that are more flexible and adaptable because they are not tied to the details of one particular implementation. Many OOP languages, object-oriented languages, have some notion of interfaces. Now, here's where I add stuff to the book, right? Go ain't an OOP language. It's just not. It always kind of frustrates me just a little bit when I'm trying to explain something and, you know, it's like, oh yeah, Go, the OOP, it does OOP stuff. Well, okay, but why even bring up the fact that it's object-oriented or not? I'm not really sure if that's like the best teaching mechanism to do. Like, why refer it to... Okay, so I'm kind of guilty of what I'm about to fuss about, but So like I'd say, oh, this part of the language is like JavaScript or C# or C++ or whatever. I'm polyglot. I write stuff with a bunch of different languages. So I know about these different features and paradigms and all that stuff. And there's this weird assumption that people should know what object-oriented paradigm programming is or functional programming is. But the fact of the matter is maybe somebody only knows top-down design. So why try to infer immediately this assumed knowledge about what is kind of relatively a complex topic, right? Object-oriented programming can be a pretty complex topic when you, especially you start using words like inheritance, polymorphism, blah, blah, blah. So my complaint is, why assume and front load things so often like that? I do it. Why am I doing it? I ask myself. But in this particular situation, like I don't really feel like I should use object-oriented programming as the paradigm to explain contracts in Go for one big reason. Okay? Let's look a little bit more about what an interface is and the contract that the interface imposes or infers in Go, and then I'll say why. It's a profoundly object-oriented language. Well, that's cool that Rob Pike did that. It's profoundly object-oriented, but you have to do like hacky stuff to get polymorphism or inheritance of any sort. It's almost like, I don't know, the more I write Go, the more I realize that when I want inheritance or polymorphism, I'm basically writing like some weird mutated version of C# where mostly all I can do is write static methods with singular right? But it's like I can only do singular signatures, singular parameter signatures. So it's a different way to look at it for sure. But it doesn't follow like, well, okay, it's kind of C++-ish. It's not C#-ish. It's confusing, kind of. But yes, using composition, right. You keep bringing up really good points, Dave. So let's see here. Interfaces. All the types we've looked at so far have concrete types. There's another kind of type in Go called an interface type. And that's the type of interface. Now we're having to redundantly use English words. This is the kind of interface that Go has, is interface types, right? It's not like an object interface. Like if you do write C#, for instance, your interface is inherited via a reference at the class level. So the class level will say your interface has fields and properties that you have to assign and declare, methods that you have to do something with effectively. In this, though, it's just a type, which then often there's just a function on the type that you have to use. So it's interesting. So let's try to do some stuff with that. Embedding field function promotion is a groundbreaking language feature that enables correct composition over inheritance design, with the goal of implementation interfaces which honors designing to descriptions of behavior rather than concretions. Yes. Yeah. That sounds good. That sounds good. I like that. I'm wrapping my head around that one. Just thinking for a minute. Dear goodness. And I'm also trying to do a slice because that's a good catch. Yeah, that is Goff. It is a Goff maxim. You're right. I have that book sitting around here somewhere. It's one of the few that I keep. Gang of Four. And what is it? Whatever the Martin Fowler Enterprise Architecture Application Blocks thing is, or whatever. Patterns of Enterprise Application. Oh, I've messed up the name of it now. But yeah, I need to reference those at the end of this session too. Check my presentation link and press N to see the presenter notes. You linked a presentation in here? Because I'll totally link that or make sure that it shows. Oh, damn it! I have turned off URLs too, I guess. Because yeah, it just went asterisk asterisk asterisk. Yeah, it dropped a link. Can you whisper it at me, and I'll just post it in here. Then we stay nice and neat. Whoops. Link, please. What is in? What presenter thing is that makes that? Oh, okay. Dot slide. So is that what exactly is that dot slide? What? And you have that on Meetup. Meetup Igu. Oh, Go Talks. Cool. Wait, so how do you go to the next slide? Oh, there it goes. It just was taking a minute for me. Just wanted to look at it real quick. I should actually pull this up in my session here. I'll show everybody what Dave just linked to me. Oh, you gotta be kidding me. Do I not have that on? I do have that on. Give me a second here, pulling it up in the link. Or pulling it up in the thing here. What the hell? Alright, I'm just going to type it manually. Give me a second. Meetup.eugogo.org and then talks.objectively harmful dot slide. There we go. Dave D's talk. Oh, I'm going through like 50 windows for this. There we go. Okay. So what exactly in your talk? Hey program, how are you today? Present tool with presenter notes. You're actually a member of the meetup. I am a member of the meetup? Cool. Firefox prevented the notes. Preferences, allow pop-ups from Yu-Gi-Oh! Cool, when I wrap up, we may come raid you. What did I just do? In. Oh, now I'm in. H to hide navigation. N for notes. I don't know how N works. Oh, is that notes supposed to be notes at the bottom? Dave Dev? Oh, there we go. Okay. That's a little weird. That's a little hard to use. But it's working. I love how it's making the background one go at the same time. Let's do this. Which one were you actually telling me to look at? Now that I'm thinking about it, I feel like I went off in the weeds there. Whether a language is object-based and also object-oriented, however. Oh, okay. Oh, you're specifically talking about the composition, which then gives what I was talking about, right? Gives the inheritance and stuff, right? Yeah, declaration of taxonomic relationships, declaration of implemented behavior sets, Magic methods. Yeah, so anybody watching, I hope, if you're just getting into Go, I hope you didn't think that I was inferring any negativity about its implementation of this. Just that I, too, am trying to figure out exactly what the thinking is behind some of these things in Go versus other languages. And my context, and also what I was describing about my frustration, is that when I'm showing or teaching or talking about some of this stuff, as I learn it or as I'm teaching it, whatever the case is, my immediate go-to is to think about, like, all right, how did I do this in, say, C#, or how did I do it in C++ or JavaScript or whatever other language that I used a particular feature. So when it's different or distinctively different, it can cause confusion at first until I figure out exactly what the pedantic semantic details are that are happening within a language, right? So that's, whoa, that's cool. Oh, that's that Spy Kid movie, right? Ooh, options. Class-based behavior sharing. That's not Go. Class-based with interface. Interface greeter, right? So this is actually a great starting point right here for class-based interfaces. I need to take a quick note here. All right, where are we at? We're at 55 minutes in this session. And yeah, that's cool. Take a slice of that too. Boom. I'm trying this slicing technique in this Twitch session, and I just don't. Oh man, thanks for the bits. I can't wait till the plugin gets fixed that I'm using for that. I'm gonna have to switch it. Program. I changed all my alerts to actually do really cool, like, rock and roll metalhead stuff. Like a sub has a total rocker come out and start thrashing and stuff. I took some music. Some of it is stuff that I've purchased to use on the stream. Some of it's stuff that I dorked around and did, and it's really rad. Like, I'm pretty stoked about it. But the one thing that doesn't work is bits. Bits still just does the like twinkle sound. That's like a default, even though I have it set. So as soon as they fix that stupid thing, bits will also get a cool, proper, appropriate thrashing alert whenever it comes up. So I'm also curious too, like yesterday's session, somebody freaked out. It's like, whoa, like this crazy guitar and stuff came on and everything whenever they did a, forget what they did. They did something that wasn't bits that caused an alert to fire. That was pretty awesome. So, all right, let's hear. Back to what we were doing. So interfaces. This is a great one, actually. Greeter interface. So everybody knows what a greeter is. If not, there's some metal clips for you. Yeah, dude. Seriously, if you want to do some metal clips, I am all open to trading on that stuff. Yeah, I hope to. I got an amp and got my guitar sitting in a corner, and I hope to actually start doing some little crazy things to add to the Twitch stream. I think it'd be pretty cool. Just do a little shredding or something. But yeah, hook me up, man. If you got some metal clips, that'd be rad. So yeah, let's actually use this and put this into code. All right, we'll use this as an example. Can I copy and paste off of your slide deck here, Dave Dev? Yeah, so I can, sort of. Let's actually, Oh, it's time to create a new thing here. Yep, get status. And let's get this in wherever, somewhere. Added additional variadic function example. Boom. Right? Commit and push. then we're gonna create a new branch. We're gonna call it interface examples. Git push origin interface examples. Boom. I don't know why I decided to do that up front, but anyway, it's in the remote repo now. I'm just going to take this junk out of here. And this stuff. And we're going to... So I didn't want to do that either. Put it up here. Alright, so we're going to interface... Oh, this is... Do you have to write public function greeter? That's a different... Oh yeah, so this is an example of that. Okay, hello. Class-based with inheritance. Class-based inheritance multiple. Alright, yeah. Class-based inheritance multiple output. Class-based inheritance. Inline drawback. Oh yeah. Hello Dan, I'm Alice. Woof woof woof. Oh man, you went. So what was this talk about? It was just like the. Trying to go back to the beginning here. Just about inheritance or interface. How inheritance lays a troublesome path. Oh, yeah. All right. So we're gonna look at your example here and just kind of. I'm gonna attempt to mutate it into Go code here. So we'll do func greeting message string, right? It kind of implement it, right? I'm not gonna do it fully. And then here, this would be type greeter interface. All right. Type. Oh, let's go for visibility as if we're writing a thing. And then func. Oh wait, we don't even declare that, right? Because it only does functions. Yeah, I was noticing the prototypal one because the JavaScript popped up and immediately like Node.js flooded into my brain. Ah, there we go. Okay. And then that's your function. Okay. I need like a thinking alert where I have Mario on metal guitar, because like every time I'm thinking, I so often have the Mario song. But you know, it's not 8-bit in my head. It's totally freaking loud, thrashy, awesome metal guitar, which I can't even hum because like you have to play a guitar to get that sound. Okay, we got greeter, and then that type's implemented, and then let's say we want to do a thing with the greeter, right? So greeter, let's do var blah greeter, right? Yeah. So then blah dot greet stuff. So I'm looking at the example in the book too. So they have printf, sprint, blah, blah, example. And then we have byte counter. I think I've just confused myself. So yeah, we did the string with string. Oh, and then we'd have to do what? Func. Okay, this one is... Now I've confused myself. What was I going to do with it? I guess I just needed to say stuff, right? So what happens there, Dave Dev? That's a good thing. You'll need to make a struct with greet method. Yeah. So that would be what? Struct greeting person, right? Of the greeter type. Oh, whoops. Am I doing that backwards? Damn it. What's the struct syntax again? Golang struct. Type name struct. Oh, yeah. Okay. Derp. Type getting person struct. Boop. And now we need to do greet. What do we need to do? Oh, we need to do greeter. Not getter. Damn it. Greeter dot. Oh, I can't type for shit. Greet. Funk, right. So I need to do, oh. Right, so how do you do that then? Yeah, so then you say return something like that, right? No, that's what you... Yeah, I don't actually know how these work. I should have read more about that. So I got a greeter interface where I declare that I need a greet function with a string. So then I do a struct greeting person. Oh, greeting person. That's a struct. And then always applies to interface types. Why is it? I'm actually confused by the book example now. Now that I look at it. So I just need to do this, right? Greet, blah, message. Whatever, message, not option, string, and then the implementation detail, right? Weird. So what did I do? I put them on the... Methods go on the outside with the syntax func. Blurg. What? Well, the U-Haul man just crashed outside. That's interesting. Func. P. Greeting person. Greet message. Wait, so like this. Func. So you're saying func. P. Asterisk. Greeting person, blurg. What? Greet. Oh. Like, whoa, okay. That is not in the right place. Yeah, the implementation examples in the book suck. And I don't actually know how this works. Text interface, streamer interface. Yeah, I'm confused in the book. It doesn't show, it just shows a bunch of interface declaration, but it doesn't talk about, like, look, check that out, I mean. Interface satisfaction right here. The assignability rule for interface is very simple. An expression may be assigned to an interface only if its type satisfies the interface. Parsing flags, interface, audio interface. So let's see here. Where's your example in this slide deck? I'm going to use it. Class-based classes, class inheritance, prototype-based example, prototype-based output, prototype-based with interface. Oh wait, is that? No, that's JavaScript-ish. That's JavaScript-ish. Yeah, and then prototype-based composition, drawback, prototype-based composition, object-based sharing. Oh, here we go. So you did this human, which has a name. Actually, let's just pull this up. Object-based example. Object-based example output. Okay. I'm going to pick apart your example then. Oh man, this thing copies crappy. Whoops, I didn't want to copy it like that. I still need the package. Ah, there we go. That copied good. Define the receiver of the method. Yeah. So we have human now. Struct will func. Okay. And then in your slide deck here. Oh, phew, I thought I closed it for a second. Object-based output. Okay, so you have a human with a name, and then you have a wolf with a whatever. I don't know what that is. Frequency. Let's say a wolf with a frequency. Oh, for his how. Okay. So he repeats it. The wolf repeats it, and then your name is Dan. So we have Dan and the wolf. Or Alice and the wolf, something like that. Okay. So then. So this is what you were talking about. Greeter. Func meet. A type in the signature list is greeter. So you have multiple greeters. Bob is the wolf, but we never name him. Oh, okay. Oh, does that actually have any sense to do with Carlos is the werewolf? Yeah, you don't have Carlos here though. Anyway, we'll go with Dan and Alice here. This looks like the example. Did I just pull the wrong thing here? Oh, there's your greeting. Okay. But you don't have the interface here. Why does that work? Okay, so we have a human struct with a name string, and then here we have a func. Oh, okay, so this is, it's not the interface though. Okay. Human and wolf types. Okay. So I'm going to steal that other example. Is this the example I'm looking for more so? Yeah, so we have, okay, greeter interface, which just has a greeting. Ah, okay, there we go. And then we have a func meet, which takes the greeter here. And then as we go through, we get the greetings in the for loop, and we print them out. And then here, what you do, let's see, what is it that you do? Okay, so you make a human. Oh, I see what you did. Okay, I'm gonna take this, boom, boom, boom. And then what do we add? So we got Alice and frequency. We got Dan, who does the meet. Okay. And then these things need to go up here. So that's what you're doing, right? So and I guess meet is not called in the second one though. Let's remove that one. Oh wait, but meet calls greeter with the greeting. Okay. And then here what you had done is meet something. Frank. Why won't my come up in Firefox? No, just there we go. So here's some meet Dan, Alice and Wolf. Okay. If I run that, what do I get? Nyan Cat running. Hello Dan, I'm Alice. Wolf, wolf, wolf. Hello Dan, I'm Alice. Okay. Oh. Oh dear. Why am I learning Go? Because I use it for a lot of things, actually. I'm learning Go specifically. How this all started was I was thrown a Go project that was written like a Java project, formatted and pseudo namespaced like a Java project, and I needed to clean it up. And I didn't really know what I was doing at the time because I had never written any Go, but I was able to, with a little bit of hacking around, take out about 80% of the cruft that a Java project would require that someone had put and imposed on the Go project, and ended up with a lot cleaner, simpler code. I did that in like about a month of diligent work. And then the other side effect that I got out of it was I could build an OS binary to execute for whatever operating system I needed it to run on, whether that was Ubuntu, Linux, or just straight up Debian, or CentOS, or Windows, or Mac OS, didn't matter. Go will build to basically all those platforms, and then I have that singular executable, and I don't need an entire ecosystem installed like in Node.js or .NET for that matter, or whatever. All I need is the executable. So I can take the executable, go to that OS, and then run it. So that is the power of Go that immediately attracted me to it. And I've been using it for a lot of system stuff, building CLIs, all sorts of stuff like that for now years. Hey, Classic Ninja. Thanks for following. And hey, that's one of the alerts that actually has the cool metal thing and the dude thrashing. So everybody got to see that now. Thanks for the follow. Let's see here. Yeah, so that is why I started using Go, and I continue to use Go because it's a relatively easy language to write. And I've been going through teaching and learning Go every Saturday for several weeks now. And I decided to do these sessions for a simple reason. I wanted to go through and figure out what gaps I had with Go. Which, for example, right now, one of my gaps is like I had never used interface or that much inheritance in Go because I simply did not need to. Most of the system stuff that I've been hacking on, the CLI stuff, didn't need it. So here I am going through interfaces, showing people what I'm doing, also learning it with all of you at the same time. So right now I'm using Dave Dev's example, Greenie 996. Is 996 like Green 996 Porsche? Is that what that's related to, or is that some other connection there? Just curious. Because it's definitely not because it's hyped. To put it simply, like I've been writing C# and Java and C++ for years, and I know all that way better, and JavaScript for that matter, and several of those other languages would make me tons more money than Go, but Go is popular. However, I have just found that it's a super useful language in my toolbox personally. Like, I use it because it's good at doing a number of things really well. Like, if I want to do JavaScript-y stuff and build a website, though, still usually default to Node.js. Because of the 99 or 6, but both were taken. Okay. I was just curious because my Steam handle is Adrian996 because Adrian was miraculously taken on Steam for some reason. So I stuck 996 on the back because what was I doing? Oh, I was driving a 996 at the time, doing some street racy, drifty stuff a billion years ago. A different lifetime, I shall say. But yeah, so every time I see 996, that's always a specific number that queues up in my head and relates to Porsche. That, and of course, the obvious 911, 911, which always cracks me up. I think of a Porsche before I think of emergency in the US, but anyway, I digress. And today, anyway, back to the Go thing. So that's the reasons I use it. And right now, I'm working through doing interfaces, which I thought I had kind of figured out. I had dorked around with it for the first time last night, and then I was like, oh yeah, sure, I can show this. And then I started dorking around with it today, and I realized that I'm a little confused by some of it still. You declare an interface like this, per Dave Dev's example, greeter interface. I have a greeter interface with a contract that needs met, a contract function or function that needs met, and it's just the signature that goes in an interface, right? Greeting takes a name and it needs to return a string. So whatever declares that it's going to meet this interface needs to meet that contract, right? It's going to meet the contract of it like you would a legal agreement or whatever. It's kind of like the legal agreement of programming in object-oriented land, which I was saying pseudo object-oriented, but Dave Dev points out that it's still pretty object-oriented, actually. It's just done in a very different way than how some past languages have implemented interfaces, because there's class interface inheritance, and then there's, what is this one? Function interface inheritance. And that's what I'm trying to figure out right now. So I'm looking through his example that he provided a little earlier. It's strictly object-oriented. Okay. So is that the wording that you'd use? Object-based with interface. Right. Inheritance is behavior sharing. But so that's the vocabulary, right, for Go away, message. Because you said object-based example was the one we started with, where there's human struct, a wolf struct, and then a greeting, and then we added this bit over here where we have a greeter interface that has the greeting message, which I put in there, and then there's a function calling it meet right here, and I'm doing some awesome copy-paste coding, and then here I was trying to get it, step through it, look at it, and make it work. So let's organize this a little bit, just for my own readability. So we have a wolf and human struct type. We'll go up here, boom. Then we have a greeter interface. So if the human or wolf, I guess they could use that, right? Here we go. So here's the greeting. So you pass in, is this even considered passing in, or is it kind of like a type declaration of the func? So anyway, you say human, so you pass that in. It's going to have a string property or field, string field name, just like wolf will have I guess this is frequency, so frequency field, which is an int. Oh yeah, okay, there we go. So it's a receiver, method receiver. And then here we have func, where the human receiver is the receiver, then greeting is the function name, name is the passed in parameter. So you'll notice this is meeting the interface requirement, right? So we're just using that as the, okay, so this is declaring this for the interface and attaching it to, oh, okay. So basically this function and this function is functionally attaching the greeting, or declaring what the function is going to do and attaching it to the human or wolf struct type. I believe is the way that I could say that. So then when you go down here and call the stuff, so like let's say you do a meet, and for each of the greeter interfaces, see, so now that these things, wolf and human, meet the interface contract of greeter, you can pass them in, as I was showing earlier with variadic functions. You can pass in a number of these things, a wolf or a human, and it steps through, just like I was doing earlier also with variadic functions, with a simple for loop, where we're skipping the index there, but we're taking G as the greeter, and then we're saying G.greeting. So then it calls the function implementation for the particular object. Do we call these objects at this point, or do we just call them structs? Struct types, and executes that particular function. So in this case, as we loop through, let's get rid of this one. Blurp. In meet, username, unused variable username. Didn't I bet? Oh. Let's do this. Right? There we go. So here, what we're doing is we're creating a human object named Alice, and then we do a wolf with a frequency of 3, so I guess that's like whoo or something like that. Dave Dev is the only one that actually knows what the frequency information means. Instance of. Okay, so instance of the struct type, pointer to an instance of. Okay, I got you. Man, verbiage is as hard as the language itself, honestly. like using the other verbiage of C# doesn't work for Go. Like I have confused more than a few people with that. And if I have confused you in the past with C# verbiage or JavaScript verbiage on top of Go to describe Go, I apologize. My bad. So now we got in func main, we have Alice and wolf that it can be identified by whoo, the frequency. and username Dan. So we're passing in Dan into the meet function, which actually does what? So greeting. Oh, so Dan then can meet whoever, and we step through each. So it should say Dan meet, right? Dan meet, or hello Dan, I'm such and such, or whoo. Oh yeah, okay. So when I run that, said earlier to avoid the common misconceptions about object-oriented. Yeah, okay, that makes sense then. I keep trying to pull that verbiage. I'm really trying with my verbiage. Like I was saying, that's like the hardest part. I figure out what little pieces do, and you can observe and see what a particular piece of the language is doing, right? But to be able to describe it, you need to understand the particular words to describe it, and that's where I get confused sometimes, or I should say quite regularly. Let's see here. All right, so yeah, that first line, hello Dan, I'm Alice, which is this function execution, right? No, wait. Sorry, it's this function execution. So hello Dan, I'm Alice is the person. And then B, as it loops through, it'll get to the wolf, and it executes the wolf's one, which is woof, and then the frequency. Oh, frequency is the number of times. Okay, yeah, that makes sense. So it says woof, woof, woof. So I guess if we said this wolf does 6, then it would bark, or woof, 6 times. Boom. Cool. So that makes sense. That's a good example, by the way, Dave. Hats off to you. Or wait, here's a hat. Hats off to you. So yeah. So human struct, wolf struct, add the interface in there. Greeting, attaching it to the human. Greeting, attaching it to the wolf. Okay. I still don't like. Actually, I think this is the first part of that book that I actually found that I'm not super stoked about. They got some other cool tweaks about interfaces where they go through and cover a bunch of stuff. Let's see, I'm trying to pull the book back up real quick so you can look at it. There you go. Yeah, like parsing with the flag.value using interfaces to do that or something. But there's some cool stuff in it, but I don't know. I don't like the basic example of what they're trying to show. So and here's this, where they're doing it with Celsius. Interface values. Caveat. An interface containing a nil pointer is non-nil. A nil interface value, which contains no value at all, is not the same as an interface value containing a pointer that happens to be nil. This subtle distinction creates a trap into which every Go programmer has stumbled. I didn't even know it was a trap to fall into yet. So, I'm going to re-reference this book again real quick. This book, really great. So even though I was fussing about this example just now, it's the first thing I found in the book where I'm like, I don't really like the immediate example that they've offered. I like Dave Divs. Dave Divs. Dave. Oh, God. I can't say your name now. Dave Dev's example better. So that one, I'm going to commit that. If you give me permission, Dave. Is that cool? Can I commit? If that's cool, I'll put that in there as an example for this session. And I'll totally give you, let's see, we're going to put this comment here. This awesome example is from Dave Dev. From his slide deck, prezzo here. Too many spaces. Go back. Let's bring it back to the beginning of that example. There we go. Start from slide 47. There we go. Cool. Kind of wish the. Oh, let's see. Read this to do. Yeah, there we go. Now it's like color coded. Cool. Yeah. There, now it stands out. Awesome. Cool, so let's go ahead and commit that one. Git status, git add, git commit, added the interface example from Dave Dev. Follow him on the damn it, Twitches. What's my git status, git push origin interface examples. And let's make sure that one is linked appropriately. GitHub.com. Glad you joined today, Dave. Otherwise, I would have been banging away at that example in the book, fumbling it probably. Hey, we would get it figured out though. So that's the thing about these sessions is no matter what, I'm going to get it figured out so that we have working examples of this stuff in the session that we can point back to and use the video or the blog entry, because I write blog entries for each one of these slowly but steadily, with examples of how the code works and what is up with the code. Alright, the link here for adding function examples, interface examples, that's the link I wanted. Then go back in here, let's add that to the README. Face example. Woo! There we go. Nice. So speaking of that, I'm actually going to work on getting that committed here. Then we'll actually jump in and we'll raid somebody here in a minute. So, program, are you still there or are you actually out hacking already? I'm going to say added interface example. Commit and push. There we go. 9 cats running along. There we go. Now if I look at that one and README, there we go. We should have both of those. So I'll sync that up in there. Well, let's see here. Who is... Oh, and I was just going to show you. So like in here, go learning. I have multiple examples. It's under my blog series too. But each one, I've only gotten 2 of them. 2 of the episodes written up so far. But in each episode, if you go back and look through, I've got additional quick link information for whatever we talked about, like the book, and also the video file itself, plus time points, so you can go directly into various time points. And as you can see below there was the code examples that you can more easily copy and paste, or refer to out to the GitHub repo itself. So that's hopefully a good resource for people trying to learn Go if they want to check it out and kind of work along with me with this stuff. And as I was saying before, there is the book example, which, I didn't transition back. Darn it. Y'all scream at me when I do that. So there's the GitHub repo, which we just did. There's the book. And then we got that added to the README. Like I was saying, I'm going to link that up. But now, let's roll out to Twitch here. And we're going to figure out who we should raid, who is going to be Program if he's already streaming, which I think he is. But let's see here, Program, boom. Whatever, browser does too. How do I fix that? Anyway, that's just in my VM, so it's not a big deal. Oh, he's still hosting me. Okay, we're gonna have to raid somebody else, dude. Are you live? Go live, dude. Let's see here. In the meantime here, I am going to roll credits, but I'm going to find somebody to raid real quick. So stay tuned and join me for our raid. Right? There's Robert Tables. We should go raid Robert Tables. And maybe even raid Don the developer. What is Don the developer? Oh, he's doing a talk show. We'll raid him some other time. We're going to raid Robert Tables right now. Raid Robert Tables. Here we go. Boom.